1, 2. Good afternoon, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelen Sindane. The lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is going to focus on the review of our prelim mathematics paper 2 that we wrote in September. Now, as we move along, I will look at certain questions from our prelim 2023 question paper, as well as some other aspects that we need to look at before we do our final preparation for the final exams, things that we need also to look at so that we are able to achieve our goals. Now, we know the structure of our mathematics paper 2. Statistics has 20 plus minus 3 marks. Analytical geometry has 40 plus minus 3 marks, so it can have 37 or 43 marks. Trigonometry also has 50 plus minus 3 marks, so it can have between 47 and 53 marks. And Euclidean geometry will have between 37 and 43 marks. The total for paper 2 is 150 marks. Now, let's look at our targets so that we are able to achieve what we need to achieve. In order for us to achieve 45%, you need to score 57 marks in paper 2. And in order for you to achieve a bachelor pass, you must at least score 100 marks in paper 2. Now, as we move along, you will see, first of all, I'll look at our information sheet. These are the formulas that we look at whenever we are dealing with our question papers. For paper 2, these are the most important formula that we look at. We'll move along. Trigonometry formula that you must know and you must use. Please, let's refer to the formula page so that we do not make and write wrong formulas or identities as we answer questions. Now, I will start with statistics. These are the aspects that we need to go through. We should look at measures of central tendency. For grouped and ungrouped data, we have to look at the mean, the mode, as well as the median. For grouped data, we calculate our estimated mean and our estimated median. Now, we should be able to determine our percentiles, quartiles, interquartile, and semi-interquartile ranges. On our box and whisker diagrams, we look at the 5-number summary and we should know how to determine it and also to interpret our box and whisker plot. And when we comment about the skewness of our data, we should know what we use to comment. Now, we also look at estimated mean. That is for our grouped data. I've talked about this. And then we also look at the variance and standard deviation, and we should be able to use our x bar minus the standard deviation to get the interval within one standard deviation. And we should also be able, with whichever value that we are given, because sometimes it can be within one standard deviation, within two standard deviation, outside standard deviation, above one standard deviation, below one standard deviation. We should be able to answer those kind of questions. We should also be able to plot and interpret ogives for our cumulative frequency curves. And we should be able to identify our outliers. We know the formula for identifying our outliers. It's given by our Q1 minus 3/2 of our interquartile range, Q3 plus 3 over 2 of our interquartile range. Anything that is outside this interval is termed an outlier, and we should be able to identify those. We should be able to use our statistical summaries to make meaningful comments and to interpret it in respect to the context that we are referring to. Now, for grade 12 statistics, we looked at our two variable statistic where we are comparing and wanting to get the association between the two variables that we are working with. We should be able to plot scatter plots. We should be able to use the correlation coefficient to make comments that are associated with the bivariate data. We should also be able to use statistical summaries to interpolate, extrapolate, and use the least squares regression line. And we should also be able to plot the regression line, which is known as the line of best fit. Now, for our statistics, our calculator is a very important tool as it helps us a lot to get our answers. We are going to look at the formula that we normally use for statistics. The first one is for our mean. Second one is for our variance, and we know that the square root of the variance gives us the standard deviation. And then that one is our least squares regression equation. And our job is to find the values of A and B. Then we are able to write down our equation. Our correlation coefficient is also very important because it helps us to comment on the strength of the relationship between the two variables that we are working with. You will find out that when our correlation coefficient is almost 0, there is no correlation, there is no relationship between the two variables. If it is between 0 and 0.25, it can either be positive or negative. You will find out that we say it's a very weak, either positive or negative association. Please, it's important that we comment on the strength as well as the sign on our correlation coefficient, because if one is there and the other is not there, we will not get full marks, because it has to be a strong positive, strong negative, weak positive. We are familiar with that table where we can look at it at a later stage. Now, this is the question that came on our prelim, and it was our question number 1. We had a survey that was conducted among a group of learners to compare the time spent on Instagram as well as time spent on TikTok, social media. Now, the information is given there. I hope these are not grade 12s because they cannot afford to spend so much time on social media platforms, yet they have a big task waiting for them in 2 weeks' time. Now, let us look at the questions. Now, remember, we are using a calculator here. We should remember the steps. So the moment you get your question paper, you have your data there, you should be able to use your calculator to put the data that we are having. We are supposed to calculate the correlation coefficient of the data. Now, we know that time spent on Instagram, we will take it. If you are not sure which one is your X and which one is your Y, you look at the scatter plot because it's given for you there, so that you do not interchange the entry of our data items on our calculators. So we'll go to our calculator, we go to statistics mode, we choose two variable statistic, and then we enter our data for our time spent on Instagram in minutes. So you will enter your 30 followed by an equal sign under the column X, and you enter the time spent on TikTok under the column Y, and make sure that you enter the data items as they correspond to each other. We do not interchange the order there. Once you are there, you are able to calculate the values of A, B. You now press AC if you're using a Casio calculator or whichever calculator that you are using to save your data. Then you are in the statistics mode, you are able to get the information. So when we calculated our correlation coefficient, we found our R as 0.96. You will get a mark for the value of R. You are supposed to comment on the strength of the correlation between the time spent on Instagram and the time spent on TikTok. That is where you are using the table that I just highlighted. 0.96 is between 0.9 and 1. So that's a very strong, our R is positive, it's a very strong positive association. So you will get a mark if you write very strong positive. So if you just write very strong, you will not get a mark, because we have to have both parts of the answer to be there for you to get the 1 mark. The equation of the least squares regression line, we found the value of A as 8.12. You get it from the calculator. The value of B, you will get it as 1.01. And then our equation is going to be 8.12 plus 1.01x. We get our third mark there. Now, some of us do not write the values of A and B separately. They just write it on the equation. So it means you'll get the mark there and the mark for 1.01 and the mark for the equation. You'll get the 3 marks on your answer. Please do not interchange the values. Make sure you write them in the correct positions. Otherwise, we are going to lose marks there. Now, we are supposed to predict the time that will be spent on TikTok if a learner spent 115 minutes on Instagram. This is the interpolation and the extrapolation that we are going to use. We use our equation to help us get. Now, if you check, the time spent is 115 minutes. It's on Instagram, and we know that that one is our X value. So we are going to use Y is equal to 8.12 plus 1.01. We substitute our 115, the time spent, and we should get our Y as 124.27 minutes. So we can round off to 124 minutes. Others rounded upwards is still fine. You'll get your answer as 124 or 125 minutes there. Others used the calculator and they got 125 minutes as the answer there. We move on to the next question, where most of us did not attempt this kind of question because it needs some bit of reasoning. It's not a straightforward where you just punch in a calculator and get an answer. So we are given there. It was noticed that 4 learners' data was not recorded. So if you check here, it's learner 1, learner 2, learner 3, learner 4, learner 5, and learner 6. So it means there are 4 more learners, which means the total number of learners that we are dealing with here, it's going to be 10. And it's no longer going to be 6 learners. Now, it was discovered that the mean time spent on TikTok and Instagram users was 73.4 minutes each. So it means our X bar is going to be 73.4 minutes. Our Y bar is also going to be 73.4 minutes. What do you know? How do we get a mean? Our mean is always given by the total divided, it's given by the sum of the data items divided by the number. So to get the total for our Instagram, we are going to say our mean, which is 73.4. We multiply it by 10 because now we have 10 learners on Instagram. We get 734 minutes. For our Instagram, sorry, for our TikTok as well, it will be 73.4. We multiply this by 10 and we get 734 minutes. Now, if we look at it, we have looked at 10 learner times for Instagram and 10 learner times for TikTok. You add the total spent there, it will be 734 plus 734. That will give us 1,468 minutes. Now, we know that in a day, we have 24 hours. So our job is to check whether the time spent on both social media platforms, is it more than 24 hours or it's less than 24 hours? Then we are able to comment. So we have added that, we get 1,468. We divide 1,468 by 60 minutes because an hour is equal to 60 minutes. You will find out that the time spent, it will give us 24.46 hours, which means it's true that the researcher commented that the total amount of time spent on the two social media platforms was more than a full day. A full day is 24 hours, and we are getting an answer of, we are saying, if we add, we got 1,468. These are minutes. We divide them by the number of minutes. An hour is equivalent to 60 minutes per hour. And this will give us 24.47 hours. And a day is 24 hours. So the time spent on both social media platforms is more than a day. So the researcher is going to be correct. We have to do the necessary calculations, and this gave us our answer of 1,468 minutes. We divided by the number of minutes per hour, then we got our answer as yes, it's more than a day that was spent on social media platforms for both social media platforms. We move on now to the next topic, analytical geometry. We always have that formula for our distance, our median, we also have our midpoint, we also have the equation of our straight line, we have the formula for gradient, and we know that the angle of inclination, the tan of the angle of inclination will give us the gradient, and we have the equation of a circle. Now, under analytical geometry, we solved questions on distance formula. We calculate distance. The other terms that are associated with distance is the length. So we are able to find the length of a line, the distance between 2 points, the gradient of a line segment. We know how to get that one. The equation of a line through 2 points, we are able to get that one. And for us to get the equation of a line, we know that we need gradient and a point. So sometimes you might not be given 2 points, but you are just given the gradient of a line or a line parallel to it, and the coordinates of a point, you are able to get the equation of a line. Now, we know that parallel lines have equal gradients. So if AB is parallel to CD, then the gradient of AB must be equal to the gradient of CD. If AB is perpendicular, we use that symbol for perpendicular to CD, it follows that the gradient of AB multiplied by the gradient of CD should give us -1. That's the characteristic we know about perpendicular lines. And we should also be able to look at our angle of inclination. It is the angle that is measured between a line and the positive x-axis. So we can have our angle of inclination as acute between 0 and 90 degrees. It would look like the first diagram. Or it can be obtuse, meaning it's above 90 degrees but less than 180 degrees. So that's our angle of inclination. Even if you are given this angle this side, that's not our angle of inclination. We'll use the property that angles in a straight line add up to 180 degrees. We determine the value of theta, and our angle of inclination is that theta, not what we are given on the other side of the line. Now, we are going to look at the equation of a circle, center AB, and we will get the equation of a circle as x minus a squared plus y minus b squared equal to r squared. So in most cases, our job is either to find the coordinates of the center when we are given an equation, or we are supposed to use information that is given to come up with the equation depending on the nature of the question. So we will answer questions based on that. The equation of a tangent to a given circle. This is where we are going to use the property of our perpendicular lines. In most cases, if you are given the coordinates of the center and a point on the circumference, you are able to determine the gradient of the radius. Once you get the gradient of the radius, you are able to also determine the gradient of the tangent. We are going to solve problems involving triangles and quadrilaterals. We should revise the properties of the different triangles. Now, I always give this question: how many types of triangles do we have? And people normally say we have 4 types. We have 3 types of triangles. We have a scalene triangle. We have an isosceles triangle. We have an equilateral triangle. A right angle is a special type of a scalene triangle because one of the angles is 90 degrees. Otherwise, it is known as a scalene triangle, a right angle triangle, or it can also be an isosceles triangle, depending on, as long as it has a right angle, it can either be a scalene or an isosceles triangle. A right angle is not a type of a triangle, it's just a special type of a scalene or isosceles triangle. We move on. We look at the concept of our circle equation. Circles that touch externally. We are able to find the distance between the 2 centers, and we are also able to find the radius of each circle. If the distance between the 2 centers is equal to the sum of the radii, the circle will touch externally like that. Then if the circle touches internally, one circle is inscribed inside the other but touches one part of the circumference of the other circle, then it means the distance between the 2 centers of the circles will be equal to the radius of the smaller circle subtracted from the radius of the bigger circle. and it would look like that. Then this was the part that was examined in our prelim question paper, where we had circles intersecting at two different points, and we were supposed to find the values of P that were accepting that. And most of us struggled to get the values of P there. And then if the two circles do not intersect, it means the distance between the two centers is more than the sum of the two given radii. And you will have a diagram like that. So the distance is greater than the radius of the bigger circle plus the radius of the smaller circle. Now, if they do not intersect at all, meaning one circle is inside the other circle, you will find that the distance is less than the radius of the bigger circle subtract the radius of the smaller circle, then the circle inside is smaller than the other one. They do not touch each other. One is just inscribed inside the other. Now, we had this question to answer. I will give you 8 minutes. No, let me give you 10 minutes to just answer 4.1 up to 4.4. And then as we do corrections, I will mention some of the common mistakes that we saw and how to overcome them. 4.1 up to 4.4. Let's attempt those questions. 4.5 and 4.6, we'll do them together. Welcome back. Now, I hope you had a good time. To just refresh your memory on some of these things. We are given, it is important that you read the information above. If some of the information is not given on the diagram, please edit to your diagram so that things look clearer. Anything with a diagram is very easy because the answer is in front of you there. All you need to do is to interpret and relate things, and then it will make more sense and it would look more clearer. Now, the first question, it says determine the equation of the circle in the form x minus a squared plus y minus b all squared is equal to r squared. Go to your formula. You are already given also the equation of that circle. All you need to do is to determine the values of a and b. Put them in your equation. So I can write this as x minus -2 because my a there, this is my a and that one is my b at the center, squared plus y minus 3 squared is equal to r squared. Now, if you check, a is on the circumference of a circle, m is the center, so I know that that line MA is a radius. So I can simply get my radius by substituting the coordinates of point A and it will give me my radius. So I will have my equation as x plus 2 squared plus y minus 3 squared is equal to r squared. If I substitute the coordinates of point A, I will have this as 1 plus 2 squared plus my y is -1 minus 3. I square that. That will give me my r squared. 3 squared will give me 9. And that one will give me 16. So I'm able to see that my r squared will be equal to 25. Therefore, my equation will be given by x plus 2 squared plus y minus 3 all squared is equal to 25. Common mistakes that we make there is to write r squared as 5. It has to be the radius squared, not the value of the radius. We got that one as our answer, and that's where we get our 3 marks. The coordinates of C. If you check, C is a tangent. You are able to see that you are going to have a horizontal line there, because if it's a horizontal line, remember the distance MC is going to be 5 units, but we are moving in the negative direction. So -2 minus 5 will get this as -7. Our y value will remain as 3. So the coordinates of C will be -7 and +3. The marks there are for the answer. We move on to the next one. The equation of a straight line. The equation of the tangent AB. Now, we are able to get the gradient of the radius. We know that the gradient of the radius, it's MA is a radius, so we find the gradient of MA or AM, and we use the formula there. We will get it as -3. We'll get it as 3 minus -1, and we get it as -4/3. That is the gradient of the radius. But we know that the gradient of the tangent, we multiply the gradient of AM multiplied by the gradient of the tangent should give us -1. We substitute our -4/3 times the gradient of the tangent, we get -1. -4/3 times the gradient of the tangent will give us -1. We'll get the gradient of the tangent as 3 over 4. That's where we get our third mark. Our fourth mark is when we substitute into our equation of the straight line, and then we'll get our equation as y is equal to 3 over 4x minus 7 over 4. That's where we get our fifth mark. We move on now. The length of BC. For us to get the length of BC, we should be able to get the coordinates of B first. The coordinates of C, we already have them. We said it's -7 and 3. Once we have the coordinates of B, our x value along a vertical line is the same. So we are going to use the equation of the straight line. And we know that the value of B is -7. We substitute into our equation of the straight line, and we get the y value as -7. So the coordinates of B will be -7 and -7. But if you check, so this is -7 and -7. BC, it's a vertical distance, so it means the distance or the length of BC will be given by the y coordinate at C, which is 3, minus the y coordinate at B, which is -7, and we'll get the length of BC as 10 units. And that is where we get our final mark there. We get it as 10 units. We get our 3 marks. We move on now to 4.5. If you check 4.5, I will add the information that I have here. -7, -7. C, we said it's -7 and +3. And we have a circle here where we are told that our x and the y-axis are our tangents. Now, the distance from the x-axis to point A is going to be 1 unit. The distance from A to the x-axis is also going to be 1 unit. Now, remember, our center is going to be that one. So the equation, our x at A, it will be x minus, this case it's x minus 1. We square that plus y minus -1. We square that is equal to r squared. Now, if you check, our radius is going to be 1 unit, because from here we have 0 and -1. Here we have 1 and 0. So if you look at the distance from here to that point, it's going to be 1 unit, 1 unit. So our radius is going to be 1 unit. Then we substitute and we get our equation as such. So you'll get a mark for the left hand side and a mark for the right hand side. We get our equation there. We move on to question 4.6. We are told that another circle with center N, where we have P and 3 as the center, and the radius of it has a radius of 4, intersects the circle centered M at 2 distinct points. Determine all possible values of P. Now, remember, it follows that now our y value will remain as 3, so we are having a scenario like that, where our circle will be like that, or our circle will be like that. Now, let's check what is going to happen there. Remember, we should be able to see what can help us. So our circle is intersecting like that, and we should see that we should have our distance between the bigger radius minus r less than the distance between the 2 points, which is also less than between r plus r. So you will find out that the distance we are going to have here 5 minus 4. Here we want to find the values of p. 5 plus 4, hence we have the 9 and the 1 there. Now, why are we having p plus 2? Because we can either move in the negative direction or we can move in the positive direction along that line where we are saying our x values are changing, but our y values are remaining the same because they are equal to 3. So either we are moving from here, that direction, or we are moving from here in the positive direction. Now, we are going to form those inequalities. We substitute our 1 and 9. And when we simplify those inequalities, you'll find out that our p will be between -1 and 7, or our p will be between -11 and -3. Now, remember, that's where we have our x as -3 somewhere here, up until we get to our -11 that side. So it means our circle can be there, or from -1, our x can be -1 until we have our x as +7 there. The circles are going to be intersecting in that particular case. We will get our marks there, 5 marks. We got the first one for 1 and 9, and then for simplifying the inequalities, we got our answer as such. Now, we will move on now to trigonometry. Trigonometry, we are going to solve problems that involve our cast diagrams where we use theorem of Pythagoras. We are going to look at the reduction formulae, our identities, special angles, general solutions, trigonometric equations, trigonometric functions. We should practice these. The effect of A, P, and K. We should also look at our compound and double angle identities. And then for today, we will focus mostly on applications of trigonometry to solve 2D and 3D problems. We are going to look at area rule, sine rule, and cosine rule. Now, these other parts, we've been doing them a lot from grade 10. I know that maybe trigonometric functions, we started doing them, grade 10 they were trimmed, but last year they were there. We started doing them last year and this year. But I know that most people struggle there, as well as the applications of trigonometry to solve problems. I will look at the questions that came in our prelim paper there, just for revision. These other parts, I know we have had enough time to look at them, but we need to keep on practicing there. Now, this is the formula we have for trigonometry in our formula page. That's our sine rule, that's our cosine rule, and that's our area rule that we are mostly going to look at today. Now, remember, for us to answer 2D and 3D problems, you are given a diagram. Identify the triangles that can help you get to the solution. You fill in the possible missing data in your diagram so that things look clearer. You start with the triangle with most information. Identify the common link between the two triangles. I will show you as we answer questions. Do not forget the trigonometric ratios that we started with. We know that sine theta is opposite over hypotenuse. if it's a right angled triangle, cos theta is adjacent over hypotenuse and tan theta is opposite over adjacent. Now, for our sine rule, please remember the proof of our sine rule, cosine rule, and area rule is examinable. So we must know the proofs as well as how to use these rules. Now, in most cases, you will find for sine rule, we are not dealing with a right angle triangle. So you must be given two sides and an unincluded angle, or you must be given more than one angle and a side, one of which is opposite one of the sides. Cosine rule, you should be given two sides and an included angle, or you might be given three sides. Then you can use the cosine rule. For area rule, the triangle will not be right angled, but we should be given two sides and an included angle, or it should be easy to determine the two sides. This was our question number 7 in our prelim 2023 question. We were given that PQT are 3 points on the same horizontal plane and MT is a vertical mast. MP and MQ are two straight stay wires. The angle of elevation of M from Q is theta. Elevation, you look up. And we know that if we're given something like, we'll be able to get the angle of depression, isn't it? Because we assume that's a horizontal plane again, so we are able to get the angle of depression if we are supposed to get it, but in this case we don't need it. The angle of elevation M from Q is theta, PQ is K meters, PM, that's our PM, it's 2 times PQ, but we are saying PQ is equal to K, so you can straight away write down the information there. PM is going to be 2K, so that you are able to see what you are working with. The area of the triangle MPQ is given by 2K squared sine theta cos theta. Now, show that MPQ is equal to 2 theta. Like I said, draw the triangle first to help you see what you are actually working with. So I'll draw triangle MPQ here so that it makes sense. My M is up there, my P is here, my Q is down there. This one is K, this one is 2K. We want to find the size of this angle. We are supposed to show that that angle is equal to 2 theta. If I look at this triangle, I'm able to use area of triangle MPQ is going to be half. I will use area rule. It is half MP times the other side, which is PQ, sine MPQ, because that is the angle that is included there. I will substitute area of triangle MPQ is equal to half. MP is going to be 2K, PQ is going to be K, sine MPQ there. On the other side, I can substitute. If I look at the area there, I have 2 and I've sine that. I can write this as K squared 2 sine theta cos theta is equal to, this will give me 2 and 2 will cancel. I have K squared sine MPQ like that. Now, I know that 2 sine theta cos theta is an identity. So I can write this as k squared sine 2 theta is equal to k squared sine mpq, or sine p. I have k squared and k squared, they will disappear. I'm left with sine 2 theta is equal to sine mp. Sorry about that. Yes, sine mpq. Now, I have a sine here and I have a sine there. It follows that therefore the angle MPQ will be equal to 2 theta. That is what we need to show. So we'll get a mark for the substitution. We get a mark for the simplification and simplifying that identity to get that sine 2 theta equal to that. And then the final mark is for us to get to that step, because this we are already given, will not get a mark for it, but we are supposed to know that if I have a sine x is equal to sine 60 degrees, the ratios are the same, so it follows that x should also be equal to what? To 60 degrees. That's how it works in trigonometry. We move to the next question. It says, hence show that MQ can be given as k square root 1 plus 8 sine squared theta. Now, we have found out that this one is 2k. We also have found out that the angle P here is going to be 2 theta. You still need to redraw the triangle so that you are able to see what you can work with. M, P, and we have our Q there. We say this angle is 2 theta. This side is 2k and this side is k. If you check, MQ is the side opposite our angle P. So we can use our cosine rule. You are able to see that the side opposite that one, we use small letter q. The side opposite this one, our m is equal to k, meaning our q is equal to 2k. Our mq, we can use small letter p there. So using cosine rule, we are able to say our p squared is equal to our m squared plus k squared minus 2 mq cosine of angle P. Or using the sides. The first side, we said the side opposite, it's our mq, we square that. M, we said this is pq squared plus q, sorry, we are having it as our, oh, I mixed up here. This is supposed to be q, not k. So pq squared plus pm squared minus 2pq times pm cosine of angle P. You can use that. Then we are going to substitute our p squared. Our m is going to be k squared plus 2k, we square that, minus 2. Our small letter m is k. Our small letter q is 2k cosine. Our angle P, we found it as 2 theta. When we simplify this, we'll get p squared is equal to, if I simplify this, this will give me 4k squared. This is k squared. We'll get 5k squared minus 2 times 2, we'll get 4k squared cos 2 theta. We have our identities for cos, double angle. Which one is going to help us? Our answer is having 1 plus 8 sine. So it follows that we should use the one that has sine. So I will write, in place of p squared, let me bring back mq squared is equal to, I can factor out k squared. Then I will remain with, it's k squared. I will remain with 5 minus 4. In place of that 4, I can put my values there. The identity for cos 2 theta, I'll use the identity cos 2 theta is equal to 1 minus 2 sine squared theta. So I will substitute 1 minus 2 sine squared theta, and I'll get my mq squared as k squared bracket 5 minus 4, negative 4 times negative 2, I get plus 8 sine squared theta. My answer is starting to take shape. So I'll get mq squared is equal to, my k squared is still there, 5 minus 4, that will give me 1 plus, I will now get 8 sine squared theta. Then my mq becomes the square root of k squared, 1 plus 8 sine squared theta, like that. And the square root of k squared, it's going to be k. That one will remain as 1 plus 8 sine squared theta. And we get our 4 marks. Substitution into our cosine rule, our identity, simplification, and answer, we get our 4 marks there. Moving right along, 7.3. If k is equal to 139,5 and theta is 42 degrees, determine the length of MT. Once again, redraw the triangle so that you are able to visualize what's happening. It's a right angled triangle, that one, where we are saying our M, our T, and our Q. Our angle here is theta. Now, if you look at this triangle, which trig ratio is going to help you find MT? We can use sine. Sine theta will be MT over MQ, which means our MT algebraically can be given as MQ sine theta. We have our calculator. Our MT will be given. Our MQ, we found it as K square root of 1 plus 8 sine squared theta. We found it in the previous question. MQ. So in place of MQ, I'll substitute, but when I substitute there, I have the value of K, which is 139,5 square root of 1 plus 8 sine 42 all squared under the square root. I close my bracket. I multiply this by sine 42 degrees. When you punch this one in your calculator, you will find the length of MT as 199,0 some meters. And the question was correct to the nearest meter. So to the nearest meter, I think we find our MT as approximately 200 meters. So even if you did not get question 7.2 correct or even 7.1 correct, but you can still get these 3 marks irregardless of the fact that you were not able to answer those, because you are using the information that you are given in the answer for 7.1, the answer for 7.2 to help you get that. And redrawing the diagram makes your life easy because you are able to visualize. Now, let us always answer these questions, because that is where we get these marks, because it's a diagram. Redraw the diagram, add information to your diagram, life becomes easy for you. We move on now to Euclidean geometry. Euclidean geometry, we are not going to look at the question, we are only going to look at one question that was in the question paper, but we'll go over all the examinable theorems and we are going to show how we do the proofs of those theorems, because that's where we can also easily get the 5 or 6 or 7 marks depending on the theorem that you are answering. So the examinable theorems: the line drawn from the center of a circle perpendicular to a chord bisects the chord. That is the first one. The line drawn from the center of circle that bisects a chord is perpendicular to the chord. This was added in 2021 in our examination guidelines. The angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circle or at the circumference. The opposite angles of a cyclic quadrilateral are supplementary. We are going to prove that one. The angle between a tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Tan-chord theorem. These, we did them in grade 11. These, number 6, a line drawn parallel to one side of a triangle divides the other two sides proportionally. We did this theorem in grade 12. Equiangular triangles are similar. It's another theorem that we did this year. Please note that a construction or a construction statement is required when proving the examinable theorems. And we use broken lines for our construction. Here is the first theorem. I will take them with you as we move along. The line drawn from the center of a circle perpendicular to a chord bisects the chord. Now, I can do my construction here. I name these angles 1 and 2. I know that they are 90 degrees. P1 is equal to P2. They are equal to 90 degrees. I make a construction using my dotted lines. So that is the first thing that you must do if you are supposed to prove a theorem. If there is no construction or construction statement, it's a 0. We stop marking because you can't do the theorem if there is no construction. What will you be basing it on? So there must be a construction or construction statement. So the first one, construction, I'm going to write, I construct OA and OB. Those are my radii. So I'll get a mark for that construction. Then, when you're proving this theorem, you must prove that the two triangles OAP and OBP are congruent. Then we must prove congruence first, which we did in grade 9. So I'll say, let's always write in triangle, you write the two triangles. In triangle OAP, and triangle OBP, you will find out that you write a statement concerning triangle OAP, you equate it to a similar statement, equivalent statement in triangle OBP. So I'll say OA is equal to OB because these are radii, two radiuses. And then also I know that OP is equal to OP. This is a common side. And then we also have our P1 is equal to P2. They are both equal to 90 degrees, and this is given. So I am able now to say triangle OAP is congruent to triangle OBP. My reason: I have a right angle, I have a hypotenuse, which is my radius, I also have a common side, so I will give RHS as my reason. So I am required to prove that AP is equal to PB. So looking at my triangle, because of congruency, it follows that OA is equal to OB. OP, I've proven that is common, so it follows that therefore AP is equal to PB, and my reason will be congruent triangles. Or I can write a full reason: triangle OAP is congruent to triangle OBP. Remember, order is very important. When you are talking about similarity and congruence, the order is very important. So normally this will be 5 marks. So 1 mark is gone for construction. The first two statements will give us a mark. The reason for congruency and the last one there, so we have 3 marks there. And then we also have a mark for AP equal to that, the reason. We will get our 5 marks there for the proof of this theorem. We move on to the new one. We were not required to prove this one before, but now we have to prove it. Again, construction or construction statement first before you do anything. So I'll write it on top here, construction. I will construct OA and OB. Then I'll name my triangles. In triangle OAP and triangle OBP. OA is equal to OB. This is a radii. OP is equal to OP. So that we see the difference, let me just try to solidify triangle OAP so that we see what we are referring to. OP, if you check, I have OP on the red triangle. I also have OP on the black triangle. It's common side. We just write common there. AP is equal to PB. This is given. Again, I can conclude that triangle OAP is congruent to triangle OBP. My reason is side, side, side. because I have stated on my statement that the sides in the different triangles are equal. It follows that, therefore, I have my P1, my P2 there as my angles, P1 and P2. It follows that P1 is equal to P2. These are angles in a straight line. Therefore, I know that the sum of angles in a straight line is 180 degrees. Therefore, I can now prove that P1 is equal to P2 equal to 90 degrees, because if I add P1 and P2, they must give me 180. So rather, let me remove this one. First, I will have the statement here, P1 plus P2 should give me 180 degrees, because these are my angles in a straight line, and therefore, if they add up to 180, it will follow that this should be equal to that, because these two angles must be equal. I'm dealing with congruent triangles, and if they're equal, they are going to give me 90 degrees. The new one also, if it's 5 marks for the construction or construction statement, you get your 1 mark. The first 2 statements, you get your 2nd mark. And then the reason, you get another mark. For P1 plus P2 equal to 180 degrees angles in a straight line, you get a mark. And then P1 is equal to P2, giving us the 90 degrees. Again here, our reason, we have congruent triangles. For statement and reason, we get our 4th mark. We move on to the next one. Yes, the angle subtended by an arc at the center of circle is twice the angle subtended by the same arc at the circumference of the circle. This one, we have 3 different versions that can be examined, but for the past years, I think the first version of the theorem is the one that is normally examined, but it doesn't stop us from doing the other versions of the theorem proofs. I will also today do the proof of the first version of the diagram. Now, let's move along. There is our question. In the diagram, O is the center of a circle. Let's read that information first, people, before we answer. P, T, and S are points on the circumference of a circle. PS, PT, and OT are drawn. Now, prove the theorem that states that SOT is that angle there, is equal to 2 times SPT. That's what we are supposed to prove. 5 marks. What is the first thing that you will do? You will do your construction, PR. Others actually put that point on the circumference, or you can just leave it where it is. You name your angles, P1 and P2, O1 and O2 there. Then, again, I will start. There are so many versions, so I will do one of the versions of the proof. In triangle, I will use in triangle P, let me use triangle OPS. I am able to see that my angle P2 is equal to my angle S. These are angles opposite equal sides. If you check, OP is a radius, OS is also a radius, isn't it? Or I can put radii, OS is equal to OP as one of the reasons there. It depends on how you want to put it. So if angle P2 is equal to angle S, if you check, I have this angle here, which is my angle O2, and I have this triangle here that I've highlighted in red. I can see that if I add this angle and that angle, O2 becomes my exterior angle of a triangle. So I can conclude that my angle O2 is equal to angle S plus my angle P2, like that. This is the exterior angle of a triangle. Then O2 is equal to 2 times angle P2, because I've said that P2 is equal to S, so it can be, I can write this as O2 is equal to P2. My reason is up the exterior angle of a triangle. I can now say similarly in triangle OPT, I am able now to say this angle T is equal to angle P1, and I know that O1 here becomes the exterior angle there. So I can now say O1 is equal to my O1 is equal to 2 times P1. Again, this is the exterior angle of a triangle. Similarly, I will start by showing that T is equal to P1, and then I'm able now to come there. So I'm saying similarly, that statement is covering the two above statements that I have made on the previous proof. I can do the same on that one. Now, I can now move on now and say my angle O1 plus my angle O2, I substitute for my O1. My O1 is 2 times P1 plus 2 times P2 for my O2. But my angle O1 plus O2 gives me my angle SOT. And if I take out a common factor here, I'll remain with 2 times P1 plus P2. But P1 plus P2 gives me my angle SPT. So therefore, SOT is equal to 2 times my angle SPT. Again, this others use variables x and y to do the proof, so it's up to you what you are comfortable with. It works, but the most important thing is to use the diagram effectively. So the first one, I will, for construction, is the first mark. P is equal to angle S, angles opposite equal sides. Then I know that my O2 using exterior angle of a triangle, I get my third mark. Similarly, I'm able to get that angle O1 is equal to 2 times angle PT, exterior angle of a triangle. I now have 4 marks. And then substituting for O1 and O2 in order to get that part, that's where I will have my 5th mark. We move on to the next theorem. Opposite angles of a cyclic quad are supplementary. What I will do, I'm supposed to prove that angle B plus angle D is equal to 180 80 degrees. So my construction should allow me to use angle B and D. I will name this angle this side as 1. I will name that angle above as 2. So my construction or my construction statement, I will construct OA and OC. Please, that one is not a straight line. So I know because the diagram looks like that, but it's not a straight line. So you construct, don't construct AC, but you construct OA and OC and name the angles O1 and O2. Looking at my diagram, my O1 is going to be equal to 2 times my angle B. Using the theorem, O1, they are subtended by the same arc, which is our AC. So these angles, so we are saying angle at center is equal to 2 times angle at the circumference. Again, if we look at our O2, O2 will be equal to 2 times angle D. O2 is that one, this part. So it is 2 times angle D. Again, this is angle at center is equal to 2 times angle at circumference. From there on, this is the easiest theorem. O1 plus O2 is equal to 360 degrees. Reason angles around a point. From there on, we substitute for O1. It is 2 times B plus 2 times D for O2 is equal to 360 degrees. Common factor is 2. We have B plus D. Sorry, that's D is equal to 360 degrees. We divide by 2. B plus D is equal to 180 degrees. Proven. Statement and reason, construction or construction statement, statement and reason. Here, O1 plus O2 is equal to angles around a point. We get our fourth mark, and then we get the substitution there to give us 360 degrees. Then we simplify to get 180 degrees. We move on to the next one, the turn chord theorem. So for our turn chord theorem, we will construct, I'm given A, B, C, D, E. I will construct BF, which is a diameter. I then join EF. So for my construction, I will construct diameter. We know that a diameter passes through the center, BF, and join EF. I will also name my angles. This I'll name it as B1. That one I'll name it as B2. This one I'll name it as E1. And that one I'll name it as E2. Now, I will start by saying my E1 plus E2, this will give me 90 degrees. Again, there are so many versions to prove this theorem. 90 degrees because this is an angle in a semicircle. I will also now have, I have my B1 plus B2 is equal to 90 degrees. My reason, I know that the tangent is perpendicular to the radius. Now, if I look at, I hope you remember this theorem, I am able to conclude that my angle, I'm able to see that my angle B2 is equal to my angle E2. These are angles in the same segment, or angles subtended by the same chord or arc. If you check BF subtends that angle, DF, sorry, subtends that angle, and it also subtends angle E2. So these two angles are equal. So I can therefore say, therefore, my angle B1, I can write it as 90 degrees minus B2. I can also write my angle E1, I can write it as 90 degrees minus B2, because I have said my E2 is equal to B2. So where there is E2, I can write B2. So therefore, I can conclude that my angle B1 is equal to my angle E1 because they are both equal to 90 degrees minus B2. So I can conclude that therefore, but my B1 is my angle DBC and my E1 is my angle E. I have proven that they are the same. So for my construction of my diameter and joining or construction statement, I'll get 1. E1 plus E2 statement and the reason, statement and the reason. Then B2 is equal to E2, angles in the same segment. And then B1 is equal to E1, statement and reason. I get my 5th mark there. Now, we move on to the grade 12 theorems. Proportionality theorem. We know that if a line is drawn parallel to the third side of a triangle, it will divide the other two sides proportionally. Here is the theorem. We are supposed to prove that AD over DB is equal to AE over EC. Now, we are going to do this construction. Others use letters H, others use K to do the construction. Remember, you construct your perpendicular height, and you also join B to E like that. You also construct height number 2, you also join D to C like that. And then you have a lot of triangles there. Now, I will use the area of triangle ADE. You are able to see triangle ADE. That's the triangle there. We are going to use the first height. It will be given by the area of triangle DBE, this one, because they are sharing the same external height, H1. We substitute, we will get the area as AD over BD. We do the same for triangle AED. That's just the naming. AED is the same as triangle ADE. We use height too, but you will realize that now we want the area of that triangle. Once again, they are sharing a common height, which is an exterior height of H2, and then we'll get that one. The area of triangle ADE and ADE is a common triangle. It is going to be the same. So remember, for construction, we had 1 mark. We have that one. So, and then the area of triangle BDE and triangle DEC, these are going to be, they are having the same base, which is our DE. Now, if you check there, these two triangles, these are parallel. It means they are sharing. If you look at this triangle, there is a height here. There is another height there for the other triangle. Same base, and they are between common height because they are between parallel lines. I'll call it H3. And they are between parallel lines, so the altitude or common height is the same. The base is the same because I drew that triangle. I also shaded. Can you see that DE is shaded twice? So this becomes a base. Our height is constructed externally, hence the areas are going to be the same. We equate the two areas, and then we also substitute. We are able to see that the areas that we got here are the ones that we substitute there. Then we have our answer there. So this one is not there. So we have our 6 marks there. The last theorem. For this theorem, you are given that the two triangles are having equal angles. We have to prove that the two triangles are similar, and we have to prove that the angles are equal. Then we are able to use the proportionality theorem. The construction, we start by doing the construction. We construct AP, and our AP should be equal to DE. We also construct our AQ, and which is equal to our DF, and then we join PQ. From there on, we are having triangle APQ and triangle DEF. You will realize that our AP is equal to our DE. This is by construction. Also, we will have our AQ being equal to DF by construction, and then we will have our angle A being equal to angle D. This one is given. So therefore, triangle APQ is similar to, sorry, it's congruent, not similar, is congruent to triangle DEF, and our reason is side, angle, and a side. This side AP is the same as DE, and the side AQ is the same as DF, and the angle A is equal to that one. So it's a side, angle, and a side. So the two triangles are congruent. So we can conclude that therefore I will call this one P1. I can now conclude that therefore angle P1 is equal to angle E from congruent triangles. It will follow that if our angle P1 is equal to angle E, it therefore follows that our angle P1 is equal to our angle B, because they are both equal to E. If angle P1 is equal to angle B, it follows that our PQ is parallel to our BC, because we have corresponding angles equal. Our angle P1 is equal to our angle B. So we will have parallel lines. And if PQ is parallel to BC, I can write that one. It will follow that our AP over our AB should be equal to our AQ over our AC. This is from proportionality theorem. We can use prop theorem as a reason because we are saying PQ is parallel to BC. But I know that my AP is equal to my DE from construction, and I also know that my AQ is equal to my DF construction. It follows that I will substitute for my AP. I will put therefore my DE over my AB is equal to my DF over my AC. Will be done with the proof. Now we have covered all the 7 theorems that we should know under Euclidean geometry. Please note, if you are proving a theorem, you must make sure you have a construction statement. Let us keep on practicing. I have put these questions for you to practice. We have our question 2 from February-March 2018, similar to the one that we answered. And then we have a free state question 4, similar also to the one that we answered. And then we also have the applications from February-March 2018, question 6. And then we also have the free state prelim paper 2, question 8, the 2023 one, to prove the opposite angles of a cyclic quad. And we have that question also to look at. Let's keep on practicing. We are going to meet again next week, where we will be addressing our maths. Enjoy the rest of your afternoon. Keep well and study well.